Hello, this is Anirudh, and this is my demonstration for the project that I've developed during my Internet of Things course. I have built a smart helmet for miners and industrial workers. I've used a variety of sensors and paired it with Internet of Things such that the data can be sent to the cloud and it can be analyzed over there where the supervisors or the people in charge can take decisions when the conditions are dire or when the miners are in danger. So the crux of this project lies within the first four sensors which I've used. There's a distance sensor which is used to detect proximity, and for now we have chosen to use it for detecting when miners fall from heights or they collapse from a lack of oxygen. We also have an RGB LED which keeps changing the color. It's still a work in progress, but that works on a bunch of conditions that are coded. We also use a DHT temperature humidity sensor and mainly an MQ5 gas sensor. So on the basis of conditions in which the workers are exposed to, the MQ5 tracks all of the gases in the hydrogen and carbon family, which are usually not that detectable but are usually harmful to workers when they're exposed to it for a longer period of time. Humidity and temperature, they are pretty self-explanatory, and during peak conditions where there's increased humidity or temperature, we would also be using that to classify whether the situation is dire or not. So there's an LED for now which displays the current readings which are going on. So for now, the LED displays the humidity and temperature levels continuously, and there's also the gas which is displayed by the MQ5. I have calibrated it using a variety of gases, smoke, and other repellents that I have found in my hostel and college. There's still a long way to go, but calibrations could be more fine tuned, and with that you could make the predictions more accurate. So for now, when this is the baseline condition where it is basically safe, the temperature, humidity, gas, distance, it's all safe. But then, like, suppose if a miner just falls all of a sudden from a height, then the LED turns, there's a buzzer, and you know there's this chance where the people surrounding him or the other workers will realize that he has fallen. There's also, suppose there's immediate changes in humidity or temperature, the LED changes color respective to that as well. So for humidity, it changes to yellow, and red indicates the worst case scenario when there's both an increase in humidity, temperature, and gas. Now, I've not just coded them on the basis of certain if else conditions. There's a lot more going on behind the scenes, and we've also used an Arduino microcontroller to power this circuit up and Node MCU to send this data over to the internet. Now, suppose if there's an increase in humidity, like I've said before, it goes to yellow, and suppose there's an increase in all of three of them, it goes to red. Testing them on the basis of you know normal environments, we couldn't get much data, but we're in the process of collecting more data. Now there's an increase in humidity, so that's there. And suppose all of them increase simultaneously, that's a dire condition, and email notifications will be sent to the supervisor as well. So all of this data is visible in the ThinkSpeak platform for real-time monitoring. We also use MATLAB to analyze them, and with the inclusion of React applications, we have sent emails on the basis of the exceeding threshold of the sensor. So now this is a certain condition where some of the parameters are passed. Sometimes it could be different, there are different conditions, but this is basically the crux of my project. The Node MCU takes care of all of the data transmission, and for future work I'm planning to planning to wirelessly implement the sensors into the helmet so that it will be more ergonomic and it can be worn more easily. Thank you.